Hi everyone, so welcome back to my channel Mathematic Girls Pati 3226. In this particular video, as you already know, I'm going to cover parts of circle. I'm going to explain you about circle here and a lot of other things, a lot of other interesting things about circle. So let's quickly start with the video. And the very first thing, okay, I have written here parts of circle, but of course the very first thing that I'm going to explain you here is the meaning of a circle. Okay, circle is absolutely a 2D shape, right? So it is a two-dimensional shape. It is a closed figure, right? It has curved boundary. It has many parts. Okay. Now talking about the parts, of course, I'll tell you about the parts in the in this video only. So yes, let us start with the definition once again. So a circle can be defined as a two-dimensional figure formed by a set of points that are adjacent to each other and are equidistant from a fixed point. What is the meaning of equidistant here? Equidistant meaning from like from the center, they are having all the points are having the same distance. Equidistant meaning is equal distance. Okay. Now that fixed point is one part of the circle. Now what is that? I'll just explain you in the video. Okay. So as the topic suggests parts of a circle, so let's first draw a circle. Okay. So this is our circle. Okay. I'm just going to explain here the parts one by one. And as I said, it is made up of, the small points adjacent to each other, which are equidistant from the center. Okay. And that is why this part is called the center of the circle. Okay. I'm just writing here A. That is the center of the circle. Center of the circle. Now the next is I used a word that like the distance is equidistant, right? That means equal distances. That is called the radius. Okay. So I'll just draw it perfectly. I'll take the straight line and yeah. So this is called the radius. If I just mark this as B. So this AB is called the radius. Okay, I'll decrease the width. I guess I need to decrease the width. So I'll just do one thing. Yeah. So this AB is called the radius of the circle. Okay, this radius is the fixed distance that I was talking about. So radius of the circle. Now there is one point I'll explain you here that if you're talking about one radius, of course we will use the word radius, but if we are talking about more than one radius, we have a different word, and that is called radii. Radii is the plural of radius. Okay, so if you're talking about more than one radius, you will use the word radii. Now how many radii can we draw in a circle? Infinitely many radii we can draw. Okay, so infinitely many radii. What is radii? Radii is simply the plural word of radius. So infinitely many radii we can draw in a circle, or you can just write down infinitely many radii are there in a circle. All right. So I'll just show you also with my invisible pen. Okay, I'll just draw the infinitely many radii. So see 1, and 2, 3, 4, 5. See, it's not fair to count these. You can just see how many radii can I draw. Infinitely many radii. These are going to be the radii. Okay. All right. Next, let's go to the next term. What if I draw? No, I have drawn one radius here. I will draw another radius exactly opposite to this radius. Okay. So what will that become? First, let me draw exactly opposite to this. So you can see this is another radius that I have drawn exactly opposite to AB. Okay. See, it does not look like a straight line, but imagine it's a straight line. Okay. So this is point C. Now this point, CD or BC, that is called diameter. So I'm just using the word BC here. and this is called the diameter of the circle. So I'll just define here the diameter as two exactly opposite facing radii. That is called the diameter of the circle. Okay, so you can see here it is, two exactly opposite facing radii. That is called the radius. So from this you can also see the diameter is nothing but double of the radius. So 2r. That is the relation between the diameter and the radius. Okay. But remember here this 2r, not just any 2r. For example, what I try to tell you here is that imagine I'm saying that this is 1r, okay, and this is also another r. So this also r plus r is coming 2r only, but that is not the diameter. Why? Because that is not exactly opposite facing radii. It should be exactly opposite facing radii, then only it will be a diameter. Now the next question is, how many diameter can we draw? So again, the answer is infinitely many radii we can draw passing through this center of the circle. Okay, make sure it passes through the center. I'm just showing you here. So how many such diameters we can draw? Infinitely many. Okay, remember that. So that is called the diameter, and infinitely many radii we can draw, infinitely many diameter also we can draw. So I'll just mark this here, and I'll just simply write down here radii or the diameter. Okay, so we can draw infinitely many diameter as well. All right, so this was like the three parts of a circle: the center of the circle, radius of the circle or radii of the circle, and diameter of the circle. And also what is the relation between diameter and radius. Now let us go to the next part, and that is a part of a circle. Okay, so again I'll draw a circle first. So this is my circle. All right, so here I want to tell you something. I hope you have heard about this word perimeter. Okay, we have found that I have made a lot of videos on the perimeter of a rectangle, perimeter of a square. What is this perimeter? Perimeter is nothing but the sum of the length of all the shapes, right? Like all the sides, I'm sorry. Sum of length of all the sides, that gives us the perimeter. So for example, perimeter of a rectangle, perimeter of a square, perimeter of a trapezium, perimeter of parallelogram. Similarly, imagine you want to find out the perimeter of the circle, right? So what do you want to find out? You want to find out the length of this part only. Now, in this case, in case of circle, we don't use the word perimeter. We use another word for that. And that is called, that perimeter in case of circle is called circumference. Okay. So this is called circumference. All right. So circumference of a circle. We have a formula for circumference of a circle. In this video, because I'm talking about different parts of a circle, so I'll not go to the circumference of a circle, like formula in detail. If you want to make a detailed video on that, let me know in the comment section. So circumference of a circle formula is 2 pi r. Although I'm going to prove some of the formulas in this particular video only, but not for the circumference of a circle. If you want me to make a detailed video on the circumference of a circle, that why is it 2 pi r, let me know that as well in the comment section. I'll definitely make a video on that. So circumference of a circle is 2 pi r. All right. Where of course r is the radius and pi is of course the value of pi. Pi is an irrational number. If you take 3.14 as the value, and if you take 22/7, that is a rational number. Okay, this is a very interesting fact about pi. Okay, let us come to the parts of a circle. Okay, so this is called the circumference, the perimeter. Now imagine I just want to find out, the perimeter from this part to this part only, right? Now clearly you can see that this is nothing but a part of a circle, a small part of a circumference, you can say. Now this small part is called arc. Now because we have here two arcs, first is this arc, another is this arc. So here the pink one we call as the minor arc, and the yellow one we call as the major arc. So I'll write down here, this is called minor arc, and this yellow one is called major arc. All right. Now, so this is called arc. Now let us go to the next part. Okay. So minor arc, major arc, I hope it is clear. Basically, arc is just a part of the circumference of a circle, but because we have, you know, two arcs here, the arc AB, the small part, and the arc AB, that is also an arc. That is bigger, that is why it is called major arc, and that is called minor arc. Now, if you want, you can just represent that, AB as minor arc AB, so that one can understand that you are talking about that particular arc. If you're talking about major arc AB, you can write down major arc AB, right? Or there is one more thing that you can do. You just put one more point here. Imagine C. So this ACB is an arc. There is a symbol for the arc. Of course, you can see there's a curved line, so you just need to put a curved line over here. That is ACB. Now you don't have to even use the word minor because it is properly, it's very clear that you're talking about the pink part only. So ACB is the minor arc. Now next is, I'll put here a word O. Okay, so this is AOB, and that is of course the major arc, right? So this is about arc. Now let us go to the next part, and that is something else. Okay, so let's do that. So this is a circle. I'm just drawing, like all the parts in a different circle so that you don't get confused, and it should not get messy. So yes. Now this is of course the center of the circle. Imagine I'm taking the arc here. Of course, I'm taking the minor arc AB. What I'll do is I will draw two radii. Okay, so what I'll do, I will draw two radii here, OA, okay, which is one of, which is joining the center. Oh, okay, I think I have to do something here. Which is joining the center of the circle to one of the point of the arc. So this is OA. It's difficult to just bring it properly. Anyway, okay. So this is OA and the other one is OB, right? Now, so this is OA and this is OB. Now you can clearly see that you are getting two areas inside the circle, right? So the area inside the circle is 2, that is this part, okay? And there is one more part, and that is the pink part, right? So we have two parts here. Now I'll tell you what is the yellow part called, what is the pink part called. We have a name for that. So yes. So yellow part you can see is made up by two radii and the minor arc. So the area between the two radii and the minor arc is called sector. And now because that is the smaller part, that is why it is called minor sector. Okay. They are called sectors. So area between the radii, the two radii and the arc, that is called sector. But this one is called minor sector. And of course, this one is called major sector. Okay. So you can see here that AOB is your minor sector. And imagine I'm just keeping a point here, M. So AMB, right? If you're saying AMB, that means you're talking about the pink part. That is your major sector. All right. So this is about the minor sector and major sector. Now let us go to the next part of the circle, and that is again very interesting. So I'll draw a circle first. And now I'll pass some lines. Okay. So I have a line here. Remember, this is called line because we have an arrow on both the ends. So this is called, okay, it has a name. I'll tell you what is the name of this. There is another circle, sorry, there is another line that is passing through the circle like this. All right, I just wanted to just extend it a little bit. I'll do it now. Yeah, perfect. So this is another line. Okay. Now, if you can notice, there is a difference between both the lines. One line is passing through through the circle at one point only. Let us take that point as D. And here it is passing through the 2 points. Let us take that as AB, right? Now, the line that touches the circle at only one point, that is called tangent. Okay. That is called tangent. So it is called tangent. And the line that touches the circle at 2 points, that line is called secant. Okay, this is called secant and this is called tangent. So both are very, very important. Now, if I ask you, is it possible, like there is a line that is passing through the circle at 3 points? No, that is not possible. So there is no such case. Maximum it can pass through 2 points and minimum it can pass through, of course, 0 points. For example, if I draw a line like this, it is not touching the circle at all, right? And of course, for one, it is called tangent. For two, it is called secant. And for this, it's just a line. We call it nothing. Okay, now talking about the next line segment. Okay, now I'm not talking about line, I'm talking about line segment, which is again touching the circle at 2 points only, but it is a line segment. That means it is fixed. Okay, see, this is the point and this is the point. Let us take this as MN. Now, this line segment which touches the circle at 2 points, this is called chord. Okay, now what is the difference between secant and chord? The very first difference is that secant is a line and chord is a line segment. Chord is, like a line segment that is inside the circle only, of course, because it is a line segment. It touches the circumference at 2 points. And secant is also touching the circumference at 2 points, but it is a line. It is just moving outside the circle as well. Now, chord is basically dividing the circle into 2 parts. Let us understand that in detail. So for that, I'll draw a circle. Now I'll draw a chord, where what is a chord? A chord is simply a line segment that touches the circle at 2 points. Okay. So this is my chord. Now this is called A. Imagine this point is A and this point is B. Now this AB is called the chord of the circle, right? Now this AB is dividing the circle into 2 parts. First is this pink part, right? And another one is that top part, okay? They are also having a name. So this yellow part, okay, I'm just not very good in drawing, so I'm just very fast here. And this yellow part and the pink part, they are called segments, okay? They're called segments, but of course, to differentiate, we need to give the word major and minor. And I hope it is clear now that which one is a major and which one is a minor. So it is segment only, not S. So this is major segment and this one is minor segment. All right. Okay. So a chord is also playing a big role here. Remember the difference between sector and segment. What is segment here? Segment is the area between the chord and the arc, you can say, right? Because AB is also an arc. AB is a line segment, of course, but if I keep a point here, M, so area between the chord AB and the arc AMB, that area is called the segment. And of course, in this case, it is a minor segment. But what is sector? Sector was the area between the two radii. Here, the radius is not there. Two radii and the arc. That is called sector, and this is called segment. Okay, I hope this is clear, the sector and the segment. Now let us go to the area of the circle. Okay. So area of the circle, again, I'll not explain you here the formula. area of the circle, the formula is pi r square, where r is the radius and pi you already know. Okay. Now let us go to one very interesting fact about chord. Okay. So for that, I'll draw a circle. Now, by the definition of a chord, I can also say, imagine this is the point, this is the center of the circle, and this is a line segment that touches the circle at 2 points. That means it is a chord. But at the same time, it is a diameter as well. So that is why there is a one very interesting thing about the chord, that the longest diameter, or chord is the longest diameter. So the longest diameter is called the chord of the circle. Is called the chord of a circle. And now from this, one very interesting statement I can give, that all the diameters are called chord, but all the chords are not called diameter. Why? Because if I draw a chord over here, that is not the diameter, but that is the chord. But if I draw any diameter, this diameter, or any other diameter, that is going to be the chord of a circle. So all the diameters are chord, but not the vice versa, not the other way around. Okay, remember this as well. Now let's go to 3 more formulas, and those 3 formulas I'll explain you in detail. So for that, I'll draw a circle. Okay. Now this is the center of a circle. I'll just draw it with my free hand. This is the 2 radii. Okay. This is point O. This is AB. Of course, you can understand that this AOB is nothing but the minor sector, right? Now I want to find out the area and the perimeter of this minor sector, right? Now, before finding the area and the perimeter of this minor sector, I also want to ask you one thing. If circumference of a circle is 2 pi r, right? Circumference of a circle is 2 pi r. This length, this arc AB, that also has some length, but that length is not 2 pi r for sure. That we need to find out. So the very first formula that we'll find out is, what is the formula to find out the length of the arc? And that is extremely simple to find it. Now, when I'm talking about the circumference of a circle, right? I'm talking about the entire, entire circle, right? That means I'm talking about this part. When I'm talking about this part, that means I'm basically taking a complete round. When I'm taking a complete round, what is the angle made at the center of the circle? That is 360 degree. Now, when I'm taking 360 degree, I'm getting the circumference as 2 pi r. Now, here I'm going to use the unitary method. What is the unitary method? To find out the price or any value for 1. So, 360 degree is 2 pi r. So, what is 1 degree? 2 pi r over 360. Right? So imagine the angle made by this arc AB at the center of the circle is theta. Okay. So if this is theta degree, so what will be the answer? Theta times 2 pi r over 360. If you want, you can simplify this. This will become theta pi r over 180. Now what is this? This is nothing but to find out the length of the arc, the formula to find the length of the arc, right? Now, to those who has not understood this, that why I did 1 degree as this and theta as this, I'll just tell you a very simple example. Imagine the price of 5 chocolates is 50 rupees. What is the price of 1? Of course, you'll do 50 by 5. The answer is 10. Now, what is the price of 100? What will you do? You will multiply this 100 with the price of 1 chocolate, right? So what is 100 times 10? It is 1000. The same thing I have done here, right? I have written for 362 pi r. So for 1, 2 pi r over 360. For theta, theta times 2 pi r over 360. I have just simplified it and I have got the formula of the length of the arc as theta pi r over 180. Where what is theta? Angle made by the arc at the center of the circle. at the center, okay, of the circle. What is R? Of course, I don't need to write it, but still I'm writing R is the radius. Pi, of course, pi is either 22/7 or 3.14. And 180 is the 180 that we have got by after simplifying the expression. Now, there is one very important thing I want to explain. I want to talk to you about pi. There are two values of pi that I have already said, 22/7 or 3.14. Now, whenever you are doing any questions on circle where pi is involved, if in the question the value of pi is not mentioned, for example, it's just given that this is the arc, this is the angle made by the arc at the center of the circle, and nothing is given about pi, and you are given that find the length of the arc, then of course we'll use this formula. But the question is, what will you take for the value of pi? Will you take 22/7 or will you take 3.14? So it depends on you. But when the value of when the value of pi is not mentioned in your question, imagine the value of pi is not mentioned, but you are free to choose any value of pi of your choice, either 3.14 or 20/7. But if the value of pi is mentioned, for example, it is written, use pi as 3.14. You have to use 3.14 only. If the value of pi is mentioned, use 22/7. Don't use 3.14. Use 22/7 only. That is it. This is what I wanted to talk about. So we have the length of the arc formula. Make sure you write it. You have the proof as well. Now, can I find out the area of the arc? Of course not. What is area? Area is the space occupied by a closed shape, right? But arc is not a closed shape. It is an open shape. In fact, it is just a curve, right? That is why we cannot find out the area. But what we can do here is we can find out the area of the sector and of course the perimeter of the sector. So for that, what I'll do is I will draw this. Yeah, I'm very sure it is not coming proper, but anyway. So this is, imagine theta degree here, right? And this is the length of the arc. Okay, this is theta degree. Okay, this is the symbol of theta. And this is your center. Now, before finding the area of the sector, I'll find out the perimeter of the sector. Okay. So we have done length of the arc. Now we are finding the perimeter of sector. Okay. Now for perimeter of a sector, of course, what is going to be the perimeter here? The perimeter is simply going to be the length of this plus this and plus this. That will give us the perimeter of the sector. Now, what is this and this? This is R and this is also R. So it is going to be R plus R. Plus length of the arc AB, right? What is R plus R? 2R. What is length of the arc AB? We just found out the formula, and that is theta pi R over 180. And this is the formula to find out the perimeter of the sector. Okay. Now, because we are done with the perimeter of the sector, we will of course find out the area of the sector as well. So for that, let us draw the circle. Let us, oh, it did not take the shape. So let us draw a circle first. Let us draw the center of the circle. Let us draw the two radii. And of course, this is center of the circle. This is the arc, length of the arc. Now, what is the area? Area is, of course, the space here, right? And now we need to find out what is the area of the sector. Again, we know that area of a circle. Area of a circle formula is pi r square, right? But is this sector complete area of the circle? No, it's just a part of the area of the circle, right? So it can't be pi r square. But we can clearly write down that if I'll take 360 degree, that means if I'll take the complete round, I'm getting the complete area, that means pi r square. If I'll take 1 degree, it will become pi r square over 360. and if I have only theta degree. For example, in this case, imagine the angle made by the arc BC at the center of the circle is, imagine, theta degree. So for theta degree, it is simply going to be theta times, which is pi r square over 360. So simply this is going to be the formula. So area of sector formula is theta pi r square over 360. Don't get confused. This is area of a sector, and that was length of the arc. That was theta pi r over 180. Okay. So make sure you write down all these formulas together, starting from the circumference of a circle, area of a circle, length of the arc, perimeter of the sector, area of the sector. Okay. You can write down all these formulas together, and you can see you can easily do all the questions. Now, of course, you can notice one thing here. You can say that this is actually area of the minor sector. How can we find out the area of the major sector? So for that, what I'll do, I'll take one question. Okay, a very simple question. For that, I'll draw a circle. Okay, and this is the minor sector. This is O, this is A, this is B. Okay, imagine this is 60 degree. Okay, imagine. I'm just not giving you the exact measurement. Imagine it's 60 degree. And this is, imagine, 7 centimeter. Okay. Now we need to find out the, first of all, the length of the, the area of the minor sector. Okay. So what is the area of minor sector? If you're finding the area of a minor sector, you have to check the angle at the center made by the minor arc only. I'm really sorry, it's minor sector, right? So the angle made by the, the length of this minor arc at the center of the circle is 60 degree. So that means theta is going to be 60. What is the formula? Theta times pi r square over 360. That is the formula. Let's just put everything. Theta is 60. Pi, let us take the value here as 22 over 7. This is r square. So r is 7 times 7 over 360. Right? Now simply this 7 will get cancelled. This 0 will get cancelled. This is 6 times 1 is 6. 6 times 6 is 36. 2 times 3 is 6. 2 times 11 is 22. So I'm getting 11 times 7, 77. 77 by 3. I'm not converting it into decimal, so you can convert it into decimal. 77 over 3 centimeters square, right? Now with this question only, you will get the question here only. Also find out the area of the major sector without any added information. So what is the one thing that you have to do is, you have to find out the area of this major sector, right? Now this major sector is also the area between the major arc AB and the two radii AO and OB. The only thing that you don't have is the angle made by the major arc at the center of the circle. But you can find it out. How? If this is 60 degree, of course, this angle is going to be 360 minus 60. So it is 300 degree. Now you have the value of theta for the major sector. So you can simply find out area of major sector by using the same formula and putting the value of theta as 300 degree. Okay. So for this, in the same question, without any added information, area of major sector is going to be theta, which is 300, times pi, that is 22 over 7 I'm taking, r square, that is 7 times 7 over 360. So 360. Purely 7 will get cancelled, 0 will get cancelled, 5 times 6 is 30. I'm extremely sorry, 6 times 5 is 30, and 6 times 6 is 36. Okay, and then you can simplify it, you can put it into decimal, and you will get the answer. All right, so that is it in today's video. I just want to tell you that I have not taken, practice questions in this particular video because this video will be very, very long in that case. So let me know in the comment section if you want me to make a practice video for all these questions where I'll be finding area of a circle, circumference of a circle, length of the major arc, length of the minor arc, area of sector, perimeter of sector, area of major sector, area of minor sector, all these questions. So I'm absolutely going to make a video on that particular thing as well. So yes, I'm hoping to see you very super soon in my next video. Till then, thank you so much for watching my video. If you are liking this video, make sure you share it with your friends and don't forget to subscribe to my YouTube channel. Thank you.